Well, good morning, ladies and gentlemen. Thank you for joining us right on time for our webinar today regarding engineering the product lifecycle. We can see that we have a number of you from all over the globe, so excuse me if I refer to UK time, but we're around lunchtime. We're going to take around about an hour of your time. We're intending, myself and Harvey, this is going to be interactive. By all means, chat in. By all means, use the technology to let us know what you think about what we're saying. And we wanted you to think, when you logged on, about the following. What do you know about how easy or not easy it is for your product to get to manufacture regarding its quality, volume and cost? Do you go down and have a look at your product being made, or are you part of the further end team, the manufacturing end? And we want you to think about what issues you have with the products or facilities that have been designed. Don't hesitate to use the chat box and the technology to both introduce yourself, and thank you for those who have, and share your thoughts on the above questions. As I've described to you, this is about engineering the product life cycle, and subsequently I'd like to introduce to you now the gentleman who's going to talk us through this piece. Here's our agenda, and here is the gentleman who's going to take us through it. On the right-hand side, my name's Andrew Bailey. I'm here to help our technical specialist, Harvey Leach, who's going to talk you through some of the concepts and theories that he's been working with over a number of years in industry. Harvey, over to you.
Okay, thank you, Andrew. First off, can I check that everybody can hear me? I've had one or two little technical glitches on the sound, so I'm just hoping that everybody can hear me. A little thumbs up from somebody there. Perfect. Thank you, guys. Brilliant. So, good morning. Thank you, Andrew, for the introduction. It's a pleasure to be here. As Andrew said, my name's Harvey Leach, and I've been working as an associate trainer and consultant with the IMechE for a number of years. I've been in training consultancy for the last 12 years, but prior to that, I spent 27 years in the automotive industry. I'm an engineer by training, and I joined what was in those days called British Leyland in 1977. Subsequently became Rover Group, BMW Group. And I started off, I'm an engineer by training in research and development. Spent a few years in then product development, working on new Rover and Land Rover vehicles. And then moved into a number of project management and then production control, manufacturing strategy type of roles for a number of years before taking up my last industrial role in the mini factory in Oxford, where my key responsibility was to liaise between the factory and the engineers doing the concept design for the second generation Mini over in Germany, to make sure that all of the challenges, some of the difficulties we'd had building the first generation car were designed out of the second generation car, so it was easier and cheaper to make. So you could say that throughout that career I sort of experienced every stage of the product development cycle, all the way through from the R&D end, through engineering, product design, into production, and then almost closing things out at the far end. And I'm hoping that I can share with you today something I learned on that journey and how I've then developed and evolved that as a trainer and consultant over the last 12 years or so. So if we move on, I get to grips with the technology. Let's just spend a minute or two looking at some of the challenges that we see as we follow a product through its life cycle. And by product life cycle, I'm talking of that whole stream of activities that start right from the sort of idea stage, so, you know, where I was in research and development in the early days, through trying to construct a project, concept design, detail design, testing, pre-production, production, products out in the field, it's being sold, it's being serviced. We have to supply components to the aftermarket, maybe even long after we've been manufacturing the original product. And I guess different organizations, those of you that, you know, the organizations you're in may give those stages different names. You might break it down differently, but I think the basic flow process pretty much works in all organizations. And a lot of our time in consultancy is spent looking at issues that occur at the late stage. And I'm just trying to move on to the next slide, and it's not moving. There we go. It's sort of a bit slow. Don't know what's happened there. But in consultancy, we spend a lot of time working with organizations in their production, sales and service end, and we notice a lot of issues coming up that we see a lot of the time that are relating to the sort of product design and development world. So we see them struggling with projects that are running late and over budget, so they're under pressure to manufacture when the development and NPI work isn't complete. You know, we've got a lot of changes because testing's thrown out problems. There's lots of changes coming into the world right at the time when manufacturing are trying to launch the product. You know, we see the manufacturing guys talking about some of the issues with the product that make it really difficult to manufacture or hold to the quality standard or make it in the right volume or at the right rate, or it's too expensive, or they're trying to deal with the complexity of having lots of variants in the product that mean they have to hold lots of stock, and sometimes they have to make decisions which variant they're building before they've got the orders for the product. So how much inventory do we actually hold? And those are tough challenges. And a lot of the time, it kind of seems to me that they're to do with the engineering, and that actually they could be much better addressed right up front in the process. So I wonder, as you know, I guess most of you listening to this call are in the sort of engineering, product development stage of production life. And, you know, one of the topics I want to look at today is how many of the issues that are seen at the sort of production and after sales end actually could be better addressed by spending more time, energy, effort and focus in the early stages of production. And that's what we're going to look at as our first topic. You know, what's the real value of doing that work up front? Because I think it's one of those ideas that maybe we acknowledge, but we're not always the best at making the most of.
Harvey, you're getting some agreement in the chat box from Gillian
Oh,
and
perfect.
Daniel, which are making observations such as complaints from manufacturing are very, very common. And that's exactly what you've just described, waiting until the product is almost about to go to market before finding out issues that I believe you're going to talk about we should have found about earlier on in the cycle. So you've got some agreement straight away, Harvey.
Perfect, good. So on familiar territory, and it's still happening. You know this. So let's just talk about the whole principle of upfront work, why it matters, because I think as engineers we have a huge opportunity to influence those things that happen at the back end upfront. You know, things like manufacturability, ease of assembly, the complexity of supply chain. I mean, how many of you as design engineers would actually recognize that some of the decisions you make actually have an influence on how much inventory of components that needs to be held in production? You know, it seems such a distant idea from product design, and yet it's quite significant. And I want to go back probably 30-something years when I first came out of the product development world and went into the environments involved in manufacturing, engineering and taking products into production. And very early in that role, my boss pulled out of his drawer a very worn photocopy of a photocopy of a photocopy of this diagram. Unfortunately, I found a slightly better copy online, but it sort of put an idea in my mind that has kind of stayed with me throughout my career. Because if we look at the percentage of the cost of the finished product, that is like that product share of the design effort, it's actually a very small amount of cost. So that's what the axis along the bottom is. But if we look at the degree of influence product design, material, production labor, business overhead has, you know, the product design stage has by far the hugest influence. I mean, in this example, you know, 70% of the cost is fixed by product design. And let's just look at that graphically. We have two lines on this graph. The blue line is showing how much cost we've actually incurred versus how much of the cost of the final product we've actually committed, we've fixed by the decisions that we've made at that point. So, you know, up to 60% of the cost of a product can be fixed at the conceptual design stage, some of those very early decisions around concept. And by the time we finish design, it can be as high as 80%. You know, so our scope to influence change, reduce the cost and complexity, diminishes considerably as soon as we've moved beyond design into sort of testing, production planning, and then as production itself, we actually start to make the product, the cost ramps up, but our ability to influence it and change it is actually very small by the time we get to that stage. So the decisions we make early, we're pretty much stuck with the cost implication of that for the rest of the life of the product. And it's the same with time. You know, if we think of engineering effort, product development effort, if we have a project where it was poorly done, executed in the start, we have a lot of work as we get towards the production phase to resolve all of the issues. You know, we might recognize that, we might put a bit more effort in up front, so we reduce the amount of work, but it's still a bit hectic, still a lot of replanning, and we long for the day when we can sort of coast home, if we like, into production. Everything's working well, we don't need to do lots of changes. That would be an ideal we strive for, and we think, you know, how do we make that upfront effort work? Because it seems like we need to get a lot more effort at the front stage for everything to happen better at the end stage. Andrew,
Harvey,
yeah.
We've got a really interesting, and I'm going to call it a commercial observation from Chris Johnson.
Yes.
I just want to pick up two comments, one from Gillian. Gillian, thanks for mailing in a little bit earlier on. Being faced with the things that are completely impossible to make once you get it onto the floor. But I want to just come back to Chris's point. And Chris is saying how much of the product design cost is influenced by the limitations on material, labour and overhead. And I'm going to call that a commercial problem. But Chris is making the observation, and it's a statement, that as engineers, we never have a completely free hand. But I can't help but think, and Harvey, please share your experience with us, a lot of us as engineers are always going to be restricted by limitations on material, labour and overheads, unless we're genuinely in a sort of innovation and creative mode. What do you think about that, these limitations, Harvey?
Yeah, I mean, I think what Andrew said is absolutely true. You know, there are always constraints. And I think my experience says you'll never get away from that. And where we can make significant moves forward is to involve the people who are designing the production facility, who are actually making the product, and say, can we make the most of this shared expertise we've had around how we manage with these constraints to minimize the effect when we're making design. And we're going to spend a little bit more time later in this webinar talking around that particular theme. Yeah? So if I may, can we just park that question for a little while, Andrew, and maybe we'll answer it in part, if not completely, as we move through the session, and if there are still some questions around that, we can maybe come back to them a little bit later on.
Perfect, Harvey, thank you.
Okay, brilliant. Because I want to just take one more idea around this thing about the impact of upfront work, and this is a little graph of number of product or process change requests going through the system. And if we take sort of organizations where it doesn't work so well, we know we see a lot of change requests at or around 2 times in a product's life cycle. The first one is when we really switch on production. So we've gone from making a very small number of products and we're having to make it at the rate that we want to sell it to the customer. So we're working up towards full volume, and we suddenly find lots of issues in assembling that product, making the parts that we didn't see maybe when we were making prototypes. We have a big spike in engineering changes. And then the second time we see a spike is when we've actually launched the product and customers start using it. And the one thing I've learned over the years is that customers find ways to abuse our products. that somehow we never ever ever managed to completely replicate within the product development and testing phase. So we get a whole load more changes that come in once customers start experiencing the product. And then we see this steady stream of changes as we move through the life cycle because we find ways to improve and develop. Now let's take this another way and say, what if we could do it something differently? So we made this sort of realization back in the early 90s, and the first project that we applied this on was actually the first generation Land Rover Freelander, where we took this really seriously because the guy who was the product project director took hold of this idea. He said, we really want to make a transformational difference on this project, and the chief engineer in the body program, which was where I was working, who was interestingly the same guy that I was working for when he introduced me to this picture of who cast the greatest shadow. He'd moved on as well, and he was really keen to put that idea into practice. And we almost got to the point where we had a competition challenge among the teams to see who could generate the biggest number of engineering changes really early in the project. You know, and I just wonder how your organization reacts to the idea of putting product change requests in, because historically in Rover, our culture was, well, an engineering change means you didn't do a really good job in the first place. You should have got it right first. So almost there was this culture where people were reluctant to introduce changes. And we suddenly switched that, or over a period of time switched it, where getting lots of involvement, getting lots of assessment, looking for all the possible ways this design could be improved, problems it might cause downstream, out on the table way before we got near production, actually became a really desirable and valued behaviour. And I won't say we got...
Harvey, what I think
yes,
you're
Andrew.
saying then is it's not about the amount of changes that you want to put in place. It's more about when you bring those changes to the table. So the more upfront that you can bring the new ideas and the different ways of doing things, and we did it like this last time and it didn't work, so let's fix it. Get those out on the table as early as you possibly can.
Absolutely, because if we're at the stage where the product only exists as an electronic concept, if you like, it is much easier, cheaper to change it, and you haven't got that real time pressure of, well, the product needs to be in the market then, so we need to start production then, and we've got to do all these changes, but by the way, we've built the factory, we're fixed to the machine, the design's frozen, we can't change it very much, we just have to make it work. So you've got much more constraints later on, and the cost and time pressure is much bigger than if we actually make driving change earlier while the design is still in the box a really desirable thing. Yeah, now that is much easier said than done, and we'll talk a little bit about how we do that in the next stage. Yeah, let me give you an example that actually is becoming quite a well-known one. It's one that appears in one of the textbooks that we recommend that goes alongside the product lifecycle training programs we run at the institution in Birdcage Walk, and it's one from Lexmark, taken by a book from a guy called David Anderson, and he quotes this, that they really looked at applying this principle of putting a lot more work in the conceptual stage. So you'll see on this example that they made the bold decision to spend something like 10 times more time at the conceptual stage, because they believed, they just had to take this leap of faith that if they did that, they would save huge amounts of time further downstream. And if you look at the picture overall, they got that product to the market 40% quicker than their previous generation products, even though they'd spent 10 times longer on the conceptual design. So the detailed design took a bit less time because there were fewer revisions. There was still a significant chunk of revisions and iterations as they got into the production engineering phase, if you like, and they got into ramp up, but actually look, they've reduced by 2/3 the number of changes as they were starting to ramp up production. So it's a good illustration from another industry of the sort of savings that can be achieved if we really grab hold of this idea that we not just spend time, but get the right sorts of inputs from everyone else across the organisation to make sure we get that conceptual design right from every perspective. So you think if we could get that effort even more effective, you wonder how much they would then have reduced that 37% on the next generation of product and the generation after that, and so on. So I think the key lesson here is, sometimes we rush too hard and we don't actually achieve the progress. We seem to be very busy, we're hurrying up, there's lots of time pressure. And my dad used to have this saying, make haste slowly. More haste, less speed. And it's really interesting that as you start looking at the literature of some of the sort of best practice companies, and in our industry, Toyota's always held up as the sort of example of one area of best practice in terms of process and product development, and a lot of people have studied it and written about it, and there's two books there, the Toyota Way and the Toyota Product Development System, that are really good reading if you want to try and get your head around some of these principles. And Jeff Leiker, who wrote the Toyota Way, captured it as 13 principles, and this one, number 13, really speaks into the topic that we've been talking about. It said, if we make decisions in the beginning phase slowly, we get agreement with everyone involved that conceptual design is right, we can then go through the implementation phase, detail design, test, introduction into production, an awful lot more quickly in the end, just as we saw in that Lexmark example. So how do we achieve that in the automotive industry? When I started many years ago, it was like every department worked in its own little silo. When they'd finished their bit, they'd kind of chuck it over the wall to the next department, and you got this linear flow of information. But of course, what that meant was, over time, you'd start getting this equal flow of complaints and change requests coming back the way, but the ones from the manufacturing guys didn't come along till an awful lot further down the program. And we thought we need to get better at this. So I've tried to illustrate the evolution of this a little bit using this diagram and some fairly crude sporting analogies, but they kind of help it. So the first thing we thought about was, well, let's do handovers. Let's actually, as we move from one stage to the next, let's do a bit of a handover. So, rather than this analogy of chucking it over the wall, which is represented by the shot putter, it's like a relay race where at least you do the baton pass. But, we suddenly, we came to realize that actually that's not necessarily the most effective. We need some of the conceptual people to stay with the project further down so they can see how it evolves, resolve problems quickly. But actually, that was still not really having the impact that we needed. And it was only when we focused really intensively on getting the input of the production engineers and manufacturing people and quality people and customer service people right up front in the project that we really made the big breakthroughs. And for me, it was a bit like a game of rugby where the ball is the product and the ball moves backwards and forwards between people with different skills, different positions on the field as it moves forward, depending on who's in the best position. So in our world, who's got the right set of skills and experiences to impact on the design at a particular phase.
Harvey, we've got some good observations that I think support that. Samantha has pointed out that in her business they have design for manufacturer sessions where design and also production people are involved at an early stage to identify issues such as the ones that you were talking about. Chris has identified also a number of the different things which can go wrong and frequently do go wrong, but only later on. It's going to cost us time and cost us money. Just while you're about to go on to this next slide, I would like our audience to think about what is it that stops us as a general rule actually identifying issues up front? Is it cultural? It's interesting really, Daniel, I've just seen two words, skepticism and reluctance. come
Yeah.
through. I've recently
Yeah,
tried
I'm just
to
about to
convince my
touch
manager,
on that topic. Yeah,
and I hadn't even asked the question at that moment. But there's a question we'd like you to think about. What is it
yeah,
that
sure.
stops you making those things early on? Thanks, Harvey. Back to you.
Yeah, no, it's fine. I mean, as this is going on, I can't really watch what's happening in the chat box because I'm sort of concentrate on what I'm saying. But as Andrew was speaking, I just looked at those last two from Richard and Daniel. I'll talk about the design freeze issue in a little bit, Richard, as well, because I think there's a plus and minus there that I'll come back to. Because I think the key thing, and I think Daniel's question sums it up, is, you know, we get the theory of this, a lot of us. You know, for some of you, it maybe adds some depth to that theory that will help you have those discussions. But actually, you know, we seem stuck with this firefighting. You know, I still do some work in the automotive industry, and it hasn't gone away 30 years after we first started wrestling in this, because it's really hard. You know, a guy called Daniel Reppening did some work with a number of the American automotive companies, you know, in 2002, so getting on for 20 years after we first started working with this. And these are real quotes from people at a couple of the American car manufacturers whose names have been disguised. But, you know, he's saying, you know, we still get this. You know, we still get this firefighting. We understand the principle that upfront is good, but actually we never seem to make it happen in practice. So, you know, I think, see, one or two people have put some comments in answering this question. You know, what are the things that really stop us doing more work and involving more people up front to prevent all this firefighting, all these late changes? You know, we see culture and time are the biggest barriers, no structured process, customer pressure to deliver quickly. Sure, yeah. Anybody got any others? It's just interesting to see what people say, because I think the customer pressure never goes away, and yet the theory and the experience of best practice says that the deliver in the end will be quicker if we spend the time up front. No guaranteed return on investment. There you go. That's a key one, isn't it? Yeah. Too many products to spend time on, so there's too much going on, so you just haven't got the capacity to do it, I guess. Yeah. Long lead time, problems with resource, need to establish the contact quickly, so ignore the raw materials. That's tricky. But then you order the wrong ones, potentially, or the wrong stuff. Yeah, lots of discussion. Oh yeah, so we're spending so much time firefighting the previous one that we haven't got time to invest in this one. This is true.
Harvey, this
People
is
in production,
fascinating because what's being demonstrated is
yeah,
a whole group of, in sometimes related issues, but in sometimes quite separate and significant issues that all of the people on our webinar today are going to be faced as they push through with significant projects, and it is going to be difficult. There's often an inertia at the start of projects that doesn't appear to be the desire to push the momentum through.
Yeah.
But I think what you're doing is really raising the awareness that a more efficient and a more effective project piece of work, if you prepared to have the fight internally and put the time in early, things will work better for you.
In principle, yeah. And so I think there's some really good points coming on there. And I think you'll see, I've kind of produced this summary slide. There are lots of reasons that have come up in the research. You know, I don't know whether I haven't seen this one pop up in the chat, but a lot of the time people keep working on projects that they know are doomed to failure. You know, they know it's gone badly wrong and they keep going and it's consuming resource, when actually either the project should be cancelled or somebody should call time and go, look, we need to go back a bit on this and try and get it right, because we're just pouring good money after bad. I think in one way or another, people have sort of picked up on the next three, you know, that says actually, I won't say I know a lot about neuroscience, but I've talked with a number of people that know the field better, and I've read a number of articles on this that say actually the way our brains work, we're not very good at connecting work we do today with a payback that comes a long time in the future. It doesn't seem very real to us. So in the fundamental way most people's brains are wired, our natural reaction is to focus on the work where we see an immediate payback, which is why firefighting is better, because you can immediately see the results. So there's this huge learning, changing our way of thinking to break this programmed mindset, if you like, that doing work now that will only get us a payback further down is something that requires a rewiring of our brains, if you like, because it's about our view of risk. You know, risk is an interesting thing, because people keep saying, oh, well, this project is bound to be better than the last one, isn't it? Therefore, the designers will have learned they'll do this, but actually it's not always the same designers, the product's different, and if we haven't actually changed anything and really had a process for learning and getting the input, what chance do we really have of making it better? So there's a big challenge there, and we kid ourselves, and I think it requires people to really wrestle with the reality of every project comes the same, and say we need to grab hold of this idea that putting resource in up front, getting it right up front, really will pay back. And yeah, sure, some projects get cancelled, but actually fewer projects will get cancelled if we get the conceptual bit right in the first time. And actually, if we look at the actual money we've spent to get it right, compared to the money we waste further downstream, in the end, it will be financially positive as well.
Harvey, and the other there's a quick question from Chris Johnson, and I think I understand the background to it. Chris has asked what sector and disciplines our audience is coming from, and subsequently, therefore, where are these observations of what slows us down? And just to let you know, Chris, I've got good sight of the attendees that we've got. We have got project management consultants on, we've got the auto industry, we've got the energy industry, we've got telecommunications, we've got aviation, and on a personal basis, I've experienced some of what Harvey's talking about in food manufacturing. So I think these sort of issues are right across the board. And I would just also like to pick up something that I think is really important, and I'm going to challenge his thinking. Ewan Brown has sent in a point which says, having no emotional attachment at the design stage or the history of the project, found it very easy to discard the old design, which was fraught with issues. And the only challenge I'm going to give you there, Ewan, and I understand it completely, is before we discard anything, let's make sure that there's nothing really decent that we ought to be keeping and that we ought to be building on. And I think your point about emotional attachment is really important. Goes back a little bit to culture. It's very, very difficult to come into something which is being driven by others and start to own it as if it was your own. And Ewan, I think that's a really good point. Harvey, back to you.
Yeah, sure. I mean, I noticed Daniel made a point about overloading it, which I didn't really talk about on the slide yet, that says, is it poor project management? Maybe, but I think it's also this sense that we want to get the most out of this valuable resource called a designer, because, really good at engineers, designers are still quite a rare beast. We're valuable people, and people think about efficiency, and therefore we go, well, we always need to make sure they've got plenty of work. So it's almost like a good thing that you've got this queue of work in progress waiting for you, but actually that whole thing slows down, puts pressure on, and I think it's more, is it project management? I think it's much more around really getting your head around the idea that people need time to think in the early stages of the project, and it's making that bold decision that we will do what Lexmark did and allow that conceptual, creational piece of a project the time it needs, and enough time so that we really will get the payback, that the design, development, pre-production phases will happen a huge amount faster if we get that conceptual bit right, as long as we get the right involvement. And I noticed there's a lot of comments about, the production people, they're dealing with the reality of today's problems, and actually for them, releasing themselves to come and talk to somebody who's doing the conceptual design for a product they won't physically see, maybe for years, is one of those tricky things. It's back to the bit about how our brains work. You know, they complain a lot about the products they've got, but actually getting to the point where they're encouraged to come and be involved in that process is really hard. And sometimes it is about a management perception. You know, see Luke's put something in there about how do management see this idea of time to think. You know, and I think it's not just a mindset change in engineering, it's a mindset change in the whole organisation. So some ideas yeah, go on.
One of the things I would hope on Luke's point is that we could demonstrate the benefits of time to think. There would be a little bit of a gap between when we were extolling the virtues of putting thinking time in up front.
Yeah.
The theory of this, of course, should be borne out by the practice that things get to market get to manufacture in a more ready state, a more efficient state, with less time of that arrow facing backwards into the design phase as everybody trots down the link saying that they couldn't possibly put this together over the timescale that's wanted. So
no,
it's a
absolutely.
challenge for us all, but we would have to demonstrate the benefits of improved profitability, lack of man time and woman time on the job, and that I think is the only way that we'll convince any sort of management, junior, senior, middle, that thinking time is not inactive time and we need to put it in.
No, but the only problem with that, Andrew, of course, is that at the time you're asking them to commit the resource and the time, you haven't designed the product, so they haven't made it, so they can't demonstrate that it's the principle works until much later. So it's almost this chicken and egg, and it needs that management leap of faith. The management need to believe in the principle, and the best you'll do is point to examples from other companies. You know, so if I look, when I joined British Leyland, it took us 7 years to get a car to market, and the cars we produced weren't actually that great from a quality point of view or a design for manufacture point of view or whatever. And typically, a new vehicle program now in Mini, in Jaguar Land Rover, and Toyota, is 2 to 3 years, and the products are so much better and so much easier to make and so on. So I'm just conscious time's moving on, and I really want to give you some ideas to things you can do to make this happen. Some of it is about project management and resource planning, making sure that we do allow for that level of resource. Projects that are in trouble, make some brave decisions. Organisations need to make some brave decisions about cancelling them or calling time to resolve problems before it gets too late, if you like, before we've committed money for tooling or production facilities or whatever. I noticed Gene Billingsley, one of my fellow trainers within IMechE, talked a little bit about phase-gated project management. I'm going to come back to that a little bit later, Gene, so really good observation. And in this case, it's about making the principle of a stage gate, so have real teeth. And I'll mention it now because it's come up, that says, we shouldn't allow projects to move beyond a certain gate stage if we can't demonstrate that the design is robust. Too often it's like, people go, yeah, I know the gate says we shouldn't move forward, but actually, the project time, we've got to meet the timeline and we'll sort it out. And kind of we don't take those type of gate stages seriously. And the other thing is, it's going to take time. There will be periods of time when we need to create resource to work up front, while we still need resource to firefight on the previous product that is battling away in the production end. So there is this, again, that's a management thing that says we need to have a period of time where we need to invest more resource in the organisation, and those are not easy decisions to make. And I guess the other thing I want to say about culture that I didn't mention on the previous slide is, who are the heroes in your organisation? If the organisational culture values the people who are good at firefighting more than it values the people who will sit and think and try and prevent the fires in the first place, then how are people going to react? How are people rewarded? And I don't just mean financially, it's what behaviours are seen as valuable. We need a culture where following the process getting the involvement up front, applying gate reviews seriously, rather than being the guy who comes in and rescues it all at the end, the hero, is a big change in culture, but absolutely necessary. And, I think probably, if we're honest, a lot of industries that we work in today have still only partially got this idea. So, as I mentioned, Gina talked about process. Let me share some ideas about that. So, we talked at the beginning of stages of product life cycle, and this is all around, really having the stages well defined. My little diamond boxes there are about, having the gate events, and it's about how do we structure that process to maximize the opportunities for concurrent engineering. So allowing the designers, the manufacturing engineers, the production engineers, the salespeople to work together rather than working sequentially. So how do we do that? And I think there's two key things. First is, have we built into that structured process real mechanisms for picking up feedback of previous projects into design? Because I know Andrew mentions one guy who said, yeah, not having the baggage meant I could chuck the old design away and start a new one. The key to that to me is, did we really understand all the reasons why the old design was bad, so we don't just introduce a whole new set of things that are wrong, and actually make sure that the new design really addresses all the things we've learned about why the old design was really difficult to make, achieve quality, achieve cost, or whatever. So one element is feedback. The other element, I think, is actually getting a culture among the design and engineering communities. They will actually go out and look and learn, and not necessarily just rely on people to come to them. I still, when we do the public courses in London, I get engineers who've been in their organisation a number of years, or they're on a graduate scheme, and I go, so have you gone and seen how the stuff is made? And it still continues to surprise me how few engineers in design-related disciplines have actually spent time going out into the factories, either in their own company or with their suppliers, to really understand how that thing they are designing is being made. So I think that's a really important lesson, because we need this continuous learning cycle. I guess a number of you who've studied anything about Lean or Six Sigma or any sort of disciplined improvement approach will know the principle of plan, do, check, act. So spend the time sitting and thinking, do the activity, and then check, did it come out the way we expected it to? And if not, do we need to adjust it? Sometimes we just plow on regardless, and we don't learn. So, what are some of the key characteristics of that? It's got to be detailed and specific enough so that it gives the designers and the developers a reasonably clear blueprint, but it needs a flexibility, because if you need to redesign the process for every new product, you don't get the consistency. We want a process within a given organisation that is consistent enough that people moving from one project to the next are familiar and recognise where they are. Have we maximised those opportunities for parallel development? And we've talked already about gate reviews and how they need to be rigorous, so I won't repeat that there. And we'll move on to some of the realities of making that happen. Here's an example. How do we make that process clear to everybody? And I did some work for one company very early in my consulting career where they had real problems. They'd just come out of a very painful new product launch where they'd had lots of changes at the beginning. The process didn't work. The cost was like 40% over budget, and they realized they needed to redesign their process. And we created this wall chart that pretty much went up on every office wall in their organisation, whether it was customer service or product development or production engineering or production. They all had this on the wall, and it said, what do we need to achieve at each stage? What are our objectives? What are the outcomes? Who needs to communicate what with who? What are the key project activities? And within each function, what are the key things they need to be contributing at that stage? And we spent a lot of time helping people understand why it mattered and what the real benefits to them on future projects would be. And it was a long it was a long haul. You know, I've talked to them since and they said, yeah, we get the idea, we're still struggling with it, but it actually made a big difference to the way people thought about projects. So I wonder, you know, how well that process is designed within your organisations. No.
Harvey, I've got a couple of I want to make a couple of observations.
Sure.
One of which, in fact, the same one I think is very significant. There's a number of mentions about lessons learned. And
yes.
I'm not really going to ask you to comment on this one, but I will ask you to comment on Chris's thinking. Chris Hyman has come in and said, Harvey, what's your view on product qualification testing? And I'm going to give you a minute to think about that whilst I talk about lessons learned. Specifically, how many prototypes should be tested? Quite often we'll test one assembly extensively and then have issues in production during factory acceptance testing. So I'm going to come back to you in a second on that one, Harvey. But the point about lessons learned, I think, is well made by Ian and a number of other people, that lessons learned can all too often be just a tick box activity. And it really has got to be something that's critically involved in the process of improving design with the aim of improving manufacture. So I think we should take that as read, but never look as the lessons learned process as something where we've just got to fill a box in, because that's not good enough. We've actually got to make that live. But have you had time to think about Chris's question?
Yeah, I have. I have, but I'm not sure he's going to be happy with my answer. But, I mean, lessons learned, I'll come back to the lessons learned thing is actually something I'm going to talk about in a minute. That's our last theme for today. I think the honest answer is we probably need a longer conversation to talk about this whole bit about qualification and testing. You know, I think if I answered the question fully, we'd have got to 1:30 and missed the rest of the webinar. So can I suggest, Chris, that maybe we connect offline and have a conversation about that, because I've got some really good thoughts and experiences on that I could share. In a nutshell, it's about, you know, building into your design thinking, what are the parameters that will actually affect how well that product will perform? So is that one product that we're testing in your case, is that actually allowing you to test for all the potential variables that will happen when that product is made? I mean, you've talked about tolerance stack up. Yeah, if you don't understand the impact of tolerancing on the manufacturability or the performance or the quality of your product, then just testing one becomes a random thing. If we understand what we're testing and can say, let's find a way for allowing for that natural variability in the tolerance stack and so on, so we understand the capability of the manufacturing processes and what variability we're likely to get, and does that affect the performance of the product or not? And then we get into something called Taguchi experiments for those who are familiar with them, and at that point I'll hold my hand up and go, whoa, I'm not an expert on that, you really need to talk to somebody there. So that's like a very quick answer, Andrew, but it's not very satisfying, because I think it's one of those issues that needs a bit more time, and I'd be very happy to have a conversation with Chris offline on that one.
That's a good idea. Thanks, Harvey. That covered it well.
Okay.
Thank you.
So let's just pick up the how-to, you know, because it's saying, how do we ensure that the guys in the design area understand the challenges of servicing a product when it's in the field? If it's a product that needs to be installed on site, as some of the things that we make are, you know, how do we understand the challenges of that? You know, how easy is this thing to install if it's going into an environment when it's snowing and raining most of the time? You know, don't think about that very easily in the design office. What about design for test? You know, how easy is it to test out some of those things we were just talking about? How easy is it to assemble? How easy is it to make the components? How do you know? You know, so I think there's three principles that we need to talk about here, and actually, you know, this is a whole day course. We do design for manufacturability as a one-day public course, which is coming up in a few weeks' time, and we talk about three things. We talk about how do we really understand the problems and the issues we've had with the current products or past products, so that lessons learned becomes something that actually means something. We don't repeat the same mistakes over and over again. Do we have guidelines that make it easy to fabricate and process and assemble and install and service and take apart? Because those can cause huge cost and delay later on. And if I have to say, in some ways, my own industry is a little bit guilty that we're very good at making cars easy to go together, but certain things are very hard to get apart. I find it really frustrating. If I need to change a light bulb on my car, I have to take half the front of the car off. But it doesn't happen as often, because everything's more reliable and there's a trade-off. So can we create the right guidelines for our products and our production processes that people know? And how do we learn? One of the best methods I've ever come across in my, talking to people in my industry and reading around it is the way Toyota used design checklists. And I didn't actually check whether there's anybody from Toyota on the call today. I know Mark Pepper, our colleague at the IMechE, suggested that a lot of these things, some of Toyota guys come on, and I always get a bit nervous if I've got Toyota guys on a course or on a session like this, because I'm talking about their way of working without having experienced it firsthand. I've only ever got it secondhand through books and talking to people who've worked in Toyota. So if there's any of you out there and you've got any comments on what I'm about to say, please chuck them in. But the key thing was Toyota believe in this thing of lessons learned. So for every product area or process area, they have what started out, as I understand, is almost like little brown notebooks where they kept records of everything they'd learned about the factors that are important when designing a particular component or a particular assembly. And all of them are simple reminders. They're checklists. They're things you can just work down, tick the box that says, yeah, I've thought about that, right, that's what we learn about that. Does my design fit within the envelope that our experience tells us will allow that product to be made and will allow it to perform to the required quality standard? So it might be graphs of acceptable and unacceptable ranges. But I think as people have commented on this call, those are either the most powerful thing in the world or the most useless thing in the world, depending on how they are used. Yeah? Because if we capture the lessons learned at the point at which we learn the lesson, so at the point when we find out it doesn't work or it really works well, we add it to the book. And then people refer to those little books, or they've now computerized the system, but they were very reluctant to, because the idea that physical books were there was really important. If people refer to those every time and add to them as they learn stuff, they become a really powerful thing. But I'm sure the experience that some of you sort of put into the speech bubbles was, the chat box rather, was about lessons learned happens at the end of the project, and how well do you remember exactly what it was that you needed to learn X months or even years later, compared to if you'd written it down and thought about it at the time? So done badly, this whole idea of design guides and checklists, is a completely worthless thing. It becomes a set of very pretty books that sit on a shelf somewhere that look wonderful, but actually they're wildly out of date and nobody uses them, so why did you ever bother? And again, if you want to read more about that book, Toyota Product Development System, and there's a proper reference for it coming up in a little while that will tell you about it. So design checklists, really good thing. Just thinking about how do we make it easy or easier for people to put these things together? Can we reduce the number of parts in our product? Maybe it's a bit higher component cost, but actually the quality and the assembly cost goes down. We love designing things, but actually are there standard components we could use because we get economy of scale, we get proven reliability? Do we think about modular design so we can assemble things in modules, test the modules, use the same module in more than one product? Do we design where all the variation is added late in production so we don't have to have lots of inventory of loads of different points because we can make the decisions later? Are we designing our product and our assembly process and facilities in parallel? And, I've skimmed over that because it's a big subject. So if there's areas in that look interesting and worth study, that's the sort of stuff we cover on the one-day Design for Manufacturability course. So please come along on that. There. So that's kind of like the end of the formal bit. We can talk about a bit of where you can get more information in a minute. So, we talked about a couple of the courses that we run. There's New Product Introduction, which covers that whole process piece, the gated process, and that's coming up next month as well. That's a 2-day course. Design for Manufacturability we've talked about. But there are a number of others. The sort of bigger boxes are really about the process and the ways of working and some of the mechanisms. The smaller solid boxes are very specific technical courses. Failure modes and effects analysis. TRIZ is a really powerful tool for innovation, and these are all programs you can find in the public course program. Here are some of the ones that are coming up very soon. New Products Introduction, Design for Manufacturability I've talked about. Design for servitization, I wonder how many people know what that means. That's really about, a lot of the time, people are buying a service of which your product is only part. And then innovation is about how do we get good product ideas right up at that conceptual end. So I'm going to hand back to Andrew now to wrap off, take any final questions. There's a book list if you want to read further on some of the things I've talked about today. Andrew.
Harvey, thank you very much indeed. And ladies and gentlemen, thank you very much for staying with us for what I hope you'll find was a really informative 60 minutes. I just want to make a comment, something that you can't see. Harvey's landed this within around about a minute of his finishing time, based on the thinking and the practice that he put in beforehand. And I know that in front of him he's got 3 indicators to tell him which slide he's on, how long exactly he's got to spend on that slide, and at exactly what time he should be in the process. So even when I've been intervening, he still managed to land it through at 59 minutes, and I think that's a great example of spending time up front to make sure that you get everything right when the thing comes to market. So Harvey, thank you for today. Ladies and gentlemen,
thank you, Andrew. It's been a pleasure.
Ladies and gentlemen, if there's anything else you want to comment on, then we'll hang around for a bit longer. One of the things I would say, we have another webinar that is planned on the 18th of November. It's going to be on Lean and Six Sigma process. You can see the slide up there now. What's the difference? Why does it matter? Please join us. I hope that you feel that this has been interactive enough. Greg, you made a comment earlier on that you couldn't see some of the comments. I'm sorry about that. We'll try and fix that to make sure that that happens next time. But for everybody who's joined us, for everybody who's commented, I hope that you found this really interesting, and that's what we're trying to do, just stimulate some thought. Wherever you are around the world, I think it's going to be Saturday tomorrow. So let's have a great weekend, and I hope you have a great finish to the week as well. Harvey, thank you again, and thanks everyone for joining us. Bye-bye.
My pleasure. Thanks, everybody. Bye-bye.